Okay, here's a question, a funny solving question with quadratics. The question is x minus 10 root x plus 9 equals 0. And the question is to solve. So I need to figure out what all the values of x are that make this statement true. When I take a look at it, I've got two x's, and typically if I have two x's, I'm going to try and factor this thing. But it's not like an x squared plus x plus something equals 0 question where I could simply factor like that. Let's get these root x's. This one is of the form of this, but you just have to do something funky to make it look like this one. And the funkiness happens here is what you do is you say, well, this root x, it really should just be a plain x. So that's what we could do is we could say let wherever you see a root x, let's call it a different letter, like p. Okay, so instead of this root x here, I'm going to have a p. And so here I've got a 10 in front of that, minus plus 9 equals 0. And now I got to get how to, like if root x is p, this thing is just plain x. And it's sort of like, I guess if you were to take root x and square it, you would just get plain x. So, and that's what I have here. So really this thing here, if I'm changing every root x to equal p, I could change this x to a root x squared, but root x is actually just a p. So really I've got p squared minus 10p plus 9 is equal to 0. That's a funky thing to do, this thing in there. And the key, I guess, is to try and see if you can see a pattern between this and what it normally is over there. Okay, now once I've got this, I'm good. P squared minus 10p plus 9 equals 0. That's a nice, easy factorable one. It's a minus there and a plus there, so both have to be minus. It's a 9, so 9 times 1 is 9, and 9 plus 1 is 10. I put a p there and a p there. So therefore, using the 0 property, I get p minus 1 equals 0. So p is equal to 1, and p minus 9 equals 0, or p is equal to 9. Now at this point, I'm thinking that I'm done, but I have to remember that back here, I let what I'm trying to solve for is x, not p. So I need to come back here and remember that actually p is equal to the root of x. So down here, instead of p is equal to 1, it's actually root of x is equal to 1. And over here, root of x is equal to 9. So if I were to solve this, I would square both sides. So I'd get x is equal to 1 squared, which is 1. And on this side, I'd get x equals 9 squared, which is 81. So my two solutions are 1 and 81. Let's just go up and check to see if those work. So if I were to put a 1 right there and right there. So 10 square root of 1 is 1. So 10 times 1 is 10. So 1 take away 10 is negative 9. Negative 9 plus 9 is 0. Yeah, so 1 works. 1 works. And 81, let's try 81 in there. So this is an 81, and this is an 81. Okay, square root of 81 is 9. Negative 10 times 9 is negative 90. So 81 minus 90 is negative 9. Negative 9 plus 9, yeah, it's equal to 0 too. So both of those work. Okay, hopefully that helps with that question. You've got to take something like this and sort of see it as being sort of that form and just use some kind of trickery here to change this root x to a normal x. And if you do that, this one up here will change to an x squared or p squared. Okay, hopefully that helps.